Hey everybody, so this is going to be a fun project. So I just worked through it on our live stream, and it took a little bit more work than I thought it was going to be. I thought it was going to be a quick, like, this is how you do this type of feature and then move on. But there was actually an underlying problem in the model that we had to go through and find and then diagnose and solve, and then we could do the actual full work through and get some really clean surfaces. So this was a exciting project, or it's an interesting project for sure, with a hidden twist in there. So I hope you enjoy it. I hope you learn something, and we'll help this guy out and get some work done.
Hello, my name is Josh, and I'm an engineer with Forge Product Development. Forge helps clients start and grow their businesses by providing affordable access to effective engineering resources. Monday through Friday, we offer a free engineering helpline live on our social media platforms, where we help answer questions from people just like you. The clips that follow were taken from one of those sessions. I hope you find it useful and enjoy.
This is the prompt that we got. So he's trying to build a bike frame. I think we actually worked with this guy previously on another project. So he's trying to build a bike frame, and he's gotten to the point where he's trying to put in some stylized chamfers in his model, right? And he's having issues with this front triangle chamfer, where when he tries to add it in, he's getting distorted shapes, right? And that can be a variety of different things. And I had to do some troubleshooting to figure out what it is, but I'll walk you through the models and see what we came up with, see what we found, and it'll be a good one. All right, so we opened his model in SolidWorks, and we're going to go through and we're going to look and see how he did his rear chamfer, and then we'll look and see how he started to build his front chamfer, and we'll see the differences in the process, and we'll walk through it all. So we'll start here. So it's good that he's using folders. It makes it nice and organized, which is good practice. So what he did here is he is offsetting these back surfaces here to give him a 3mm offset edge on these inside surfaces, which is where he wants his chamfer to terminate on the back side. So we're going to call this the back side, and this is going to be the front side, just for, because that's the way it orients when you bring in the model, and just for some terminology. So he's offsetting the surfaces, which is fine. He's deleting the hole out of that surface. Yeah, so there's some rebuild errors here, right, when we open the model, and I'm not quite sure what's causing those, but it doesn't really affect what we're trying to show or teach. So we're just going to ignore those. Obviously, if this was your model, you'd want to figure out what the problems was. But for now, we'll just ignore them. So we can see that he's offsetting the surfaces, and he's deleting the hole out of the inside so that he can use that to generate split lines, which is great. Generating split lines, and now he's building split lines again using this sketch that he's created. And that's defining where his chamfer ends on the on this side, on the front surfaces here. So he does this, and then he lofts between them, and this is where we'll kind of show a different technique later. But he's going to loft between those surfaces, and then he's going to use that loft and extend the loft, and then use a surface cut with that loft to cut away the material and leave him with his chamfer that he wants. Now, one step I would add in this is once you do your split lines, and definitely once you kind of complete this whole folder, is I would go and I would add in a delete keep body feature, and I would delete out all of the surface bodies that you created to do those features. And that's better than suppressing them, because it just completely removes them from your tree, and will help with rebuilds and clarity and stuff like that. So we've used the features. We used those surface features, so now we can delete them out because they serve their purpose. And now we can actually see what we're left with here. So we can hide this sketch, and we'll see that's not bad. It's not bad, right? It's a decent chamfer. We can evaluate it using zebra stripes. It's not too bad. Looks pretty clean. which is fine. I mean, we've got some weird stuff going on down here in the corners a little bit, but all in all, it's not a bad way to do it. Now, I'll show a preferred way to do it. I'll show one, a faster way, and then two, the preferred way that's more robust and was interesting when we started doing it. So that's one way to do it. Now he's saying he's having issues with this front chamfer, and let's walk through his process there and see what he's done. So he's repeating the process, which is fine, right? Surface offset, good. Delete the hole, good. Use that surface that's now a continuous surface to create a split line, and then using another sketch to define on the front face where we want those chamfers to terminate at, right? So there's our sketch giving our defining our chamfer shape. So using that to create split lines on these surfaces, everything's good. Now he starts to create control curves for his loft face, which we can see here, using a 3D sketch, which is fine. I'm going to turn off our curvature combs to clean this up. And one issue I have with this technique so far is that you can't see the surface that you're creating, right? Because it's inside the solid. And he actually had the same problem back here. He didn't know what he was getting in this process until he actually cut it out, which is like a whole nother feature after this. Like, you're building this lofted surface, but you can't see what it really looks like unless you turn on curvature combs and you're trying to read these in the mesh preview. So what I might suggest doing is, since you're building a surface loft anyways, after you do your split lines, you go to surface and you're going to delete the faces that you just created using your split lines. We delete all of this out. And when we do that, it's going to convert our solid body into a surface body. But it's going to open up where our chamfer is going to go. And I talked about a really quick method to do this earlier. When you do delete face, there's an option to patch down here or fill. And if you do delete and fill and click the check mark, it'll think for a minute. Ooh, I had tangent fill on. Hold on. Take this tangent fill off. And it'll actually create that chamfer for you. Now, it looks really good. And it is pretty good, actually. If you go in and you evaluate and you do zebra stripes, you'll see that one is one giant continuous surface, so that's not bad. And it's not terrible. You don't really see any issues with it, right, at first look. Or anything really glaring. Not bad for using one feature and just clicking a box, right? But I'll show you here in a minute. There's actually a problem, and you don't see it yet, but it's there. It's the whole reason why he's having issues with his loft. So anyways, let's keep going with his process, and we'll see what he kind of ends up with. So delete the face, right? He used a 3D sketch to create control curves, which is good. Using a loft, which is fine. I might use boundary surface instead, but that's fine. Loft is fine. And we're going to use boundary surface later when we use like a really robust technique to kind of show you how to solve this if you were having issues, which he is. So he's creating a loft, right? And we're going to go in and we're going to use that 3D sketch that he has here. Now, when he sent the model, he hadn't selected these as guide curves yet. I was saying control curves. They're actually technically called guide curves. So we want to show the guide curve sketch And one issue he's going to have is that it's not going to let you select them. And that's because they're currently set to reference edges or reference. So we'll get out of here. 3D sketch, go into here. We'll select all of these lines and turn off work instruction. And then it'll make it easier to select them within Surface Loft. So, somebody in the comments to this post had said, well, the issue is that you didn't have guide curves in, which is a good start, right? So guide curves help the software figure out what the surface should look like. And if we add all these guide curves in and solve, we get this surface here. So the guide curves did help in that they eliminated that big bump he was having in here. And I'm not sure if we showed that or not, but when you solve or when you use the Surface Loft originally without the guide curves, it would put a big bump in here, which is not what we want. And so now with the guide curves, we can see that the surface is much better. But there's one glaring issue here, and it's this line right here. This line, the way I have my settings set up, is that if a edge is tangent, you'll see that it shows as a dotted line. And if it's a hard break, if it's a coincident edge, it'll show a solid. And this edge here on our nice smooth fillet is coincident. It's not tangent. So we can go to evaluate, turn on zebra stripes, and it's kind of hard to see because it's not off by much, but it is off. We can see right here, right? This black is not in line with this black across this edge, which means that we're not tangent. And that's something that we didn't see really easily or as easily when we did the delete face version of this, where we just clicked the patch and then it built it for us. When we looked at the zebra stripes, we didn't pick up on this right away. And when you're using this loft feature, it's more apparent because it's putting an edge in here. So originally I thought, okay, the loft feature is just failing. And what we need to do is we need to build this in a more robust method, which would be to build each of these faces with a boundary surface, right? So what I proposed or thought was going to be the solution is to delete this loft face. And instead of doing that, we're going to turn off this patch. Just going to make this delete. All right. Another thing that he did that you don't see it originally when it's in the tree is when he was using that loft feature, he had created these two 3D sketches to define, I believe they were to define the split lines, because I think they're referenced directly from the split lines, and we don't need them. So we could actually take them out. And when we're selecting our geometry for our surfaces, we want to be using the edges from the surfaces, not a 3D sketch that has referenced in the edges from the surface. You want to go directly to the most stable geometry, which is going to be the edges. So that's going to break this sketch, obviously, because when it was created using the other 3D sketches as reference. So we can go in here really quick and fix this up. So we're just reattaching these to the actual surfaces instead of a 3D sketch that was referencing the surfaces. And he did a good job putting in the location of these lines, right? So he's sectioning out his flatter, straighter pieces with the more curved sections, which allows SolidWorks to solve things in chunks. And just try to, instead of trying to do all the heavy lifting in one shot. And when you're selecting locations for these lines, you want the, you want to try and select angles where the line is mostly perpendicular to both edges that it's attaching to, the rails, you could call it. So when you're building big flat surfaces like this one, between this edge and this edge, right? We want them to terminate into nice square corners as much as possible. So we'll look over here and we see that this is an issue over here where we have this kind of come out and we have it in a small angle here and a large angle here. And we can kind of move that. We can move this one a little bit to have closer to right angles on this surface. All right. So they're not fully defined, right? Because I can still drag them along the curve, but we're not going to worry about fully defining them right now. Best practice is to fully define it. But for a feature like that, it'll be fine just to show you for educational purposes only. All right. So we deleted the face out and we rebuilt our 3D sketch instead using the correct edge geometry as our references in this 3D sketch. And now, originally I thought, okay, well, our lofted surface failed. If we break this down into individual surfaces, which is more robust, that should solve the problem, right? You would think. So what I originally thought was going to be the solution is to come in here and start building boundary surfaces. All right, so we're selecting our boundary. Yeah, boundary, not filled. So we're using boundary, not filled, because we have a four-sided surface, which is what boundary surface was pretty much made for, right? I'm gonna, whoa. Yep, good. So we selected our edges, made our surface perfect. Now we're gonna come over here. You're gonna start with your flat surfaces first, which are more flat, more square surfaces first. And this, we're selecting our edges. Right? Building nice flat panels, edges. This is a little bit interesting in that there was a disconnect here, right? This should have been all one flat panel or one flat surface like this. And instead it pulled this edge down. But you can see that it is tangent, right? It's not like before where it was a solid line. So this is a tangent line across here, but still interesting that it did it. So we might need to keep an eye on that. But what's interesting is when we come over here. So I thought loft was failing, right? And now that we have two edges on to do this corner, we'll turn off the 3D sketch and use the actual edges. So boundary surface again. I thought loft was failing in this corner, and it was a loft issue. And so I thought using boundary surface and having the curve or having these surfaces on the side already, our big flat panel surface, our references, our primary surfaces, having primary surfaces in there would solve all our problems. So I thought, okay, well, we do this, we build our boundary surface in the corner and problem should be solved, right? Nope. So I was like, okay, well, that's a weird spot for, like, that's the same location, right? Why is it doing that? And the problem actually stems. Now you could build all the other surfaces out and they build up fine, but this corner still fails. This is the same corner that had the big bump in it, the same corner that has this discontinuity, this non-tangent edge when you use the loft feature. The delete face fill hid this, but when you go to use a different feature, it starts showing up. I was like, what is wrong with this? So I went in and I added, I'm like, okay, it's having an issue building across this point here. So I went in and went to the 3D sketch that we're using, right, for these lines. And I put one in here. And I think I put it somewhere around here, trying to keep it coincident. So I put an edge in here. I was like, okay, well, I just need another, something's up with the curvature of, going from this circle here up into this edge, right? I was like, okay, well, there's more control points up here. Maybe it's having an issue there. Maybe we just need, more control curves. And it turns out that didn't fix it either. So after running into this wall and trying to brute force it by putting more control edges in here and breaking this down into more surfaces, we found out what the problem was. If you go to the back side of this part and you look at it, this is a solid line, right? Which doesn't seem like it's a big deal, right? So this surface here is not tangent with this here, which is okay. It's not a big deal, but it is a big deal when you use these surfaces and you offset them to create the split lines here. What's happening is, we'll go back up the tree. We're offsetting a surface that has a non-tangent edge in it. And so when we use that surface to create these split lines, right? We're creating these split lines. There's actually a discontinuity right here on this split line that's non-tangent. And we delete out our faces, and we no longer see, and it's really hard to tell, right? Because this surface doesn't have an edge here. Like, this line ends here, right? But this surface doesn't have a line on it showing that there's a discontinuity. So this edge and this edge are non-tangent, and that's what's creating the issue. It's actually creating it over here on the corner. So the solution to this is we have to fix the discontinuity back here when we offset our surfaces. So I'll open up. This is a model that I worked through previously. So what we did is all the way up here, and when we're building out this solid, we put in a fillet. And that's to create a continuous curve through here, so that when we offset our surfaces, when we offset this surface, we can select this. And we'll see now that that discontinuity that used to exist right here is now all these surfaces are tangent to each other. And when we do that, and we go back down and we build up our surfaces, everything builds out much smoother in this corner. You can see that that tangent, or that coincident line, which was running from here down to the point where the tangency was broken, that's now gone. This is much cleaner. Much cleaner surface, right? Looks really good. And you can go back in and even see the curvature combs. Are much cleaner. So that's really the trick, right? Is that that hidden discontinuity is what was causing the problem. And even though I thought originally it was a process issue, it was a feature selection issue, it was really this back here, this hidden discontinuity that was causing, no matter what features you tried to build with, to fail. So yeah, that's how that is the robust way of doing these type of fillets. Just to review, kind of just define your edges however you want to do it, whether that's using a surface offset or whether that's using a sketch to create your split lines. I would delete out those faces once you have them split so that you can see into the model and see the surfaces that you're creating. You can use delete face to create that all in one shot, but it might be hiding errors, so just be careful. Then you build up boundary surfaces. Use your flat ones first, your primary surfaces. And then you can go in and build your secondary surfaces that have more curvature and reference your primaries. Make sure you're using edges. Don't use 3D sketches that have the edges converted. You can use 3D sketch to create your support curves through here. And yeah, once you've created all those surfaces, you'll end up with a surface model that doesn't have a solid in here, right? Because we deleted the faces on the solid, creating a surface model. So then all we have to do is go in and we use surface knit. We're going to select all of our surfaces now, including the main body, which is also a surface. We're going to do create solid. Make sure that's checked. And since it's a watertight enclosed surface, it will add material back to the inside. You'll see as we come up through here, there's material in here now. And then that's pretty much it. That is the process that I would use to build up fancy, pretty fillets like this. And if you use curvature, continuous curves when you're defining these, you can get higher orders of continuity, like G2, G3, that type of stuff. But for this, just doing tangency is also probably fine. I hope this was helpful to you. I hope that you learned something and helped solve the problem. It also goes to show that even though you might be using features that are correct, there might be underlying problems that you have to try and work through and solve. So that was kind of a cool surprise. If you like this type of content, please leave a like and subscribe. It does a lot to support the channel. Still new to this, and every subscriber means a lot. Also, if you wouldn't mind going to LinkedIn and following Forge Product Development on LinkedIn, we'll be able to live stream over there, which will help us a lot to grow and reach the people that we're trying to reach. I hope you enjoyed this helpful session, and feel free to send questions either in the comments or to us directly. We'd be happy to take a look at your project. Have a great day, and thank you.